Hello, welcome back to our little series. We are making a mini Rust in Rust. We have got to the point where we can add two numbers together. This is video 10, did I say that? And yeah, so we can do things like give it a program like 11 plus 2222, pass it into our code, and it comes back with the answer, 2233, and it tells us a type. So it's not a very neat output at the moment, but yeah, this program is sort of a program, I guess. I mean, it's not a valid Rust program yet, so we haven't got there yet. Does execute. We're writing an interpreter, so we're not compiling it into machine code and then running it. We're directly understanding the code and running it. And then we've got where we've got to is, and I did a little bit of this off video just because you'd seen enough of me fiddling around with these miet errors, I think. But yeah, so if we have something that looks like a number to the lexer, but then when the evaluator tries to actually turn it into a number, it doesn't fit in an I32, we get an error from the evaluator. Maybe there should be a nicer error message than that. We'll probably get to that. We're going to find a way of comparing what we do with what Rust actually says, but I think we need a bit more before we do that. But yeah, so you can see these lovely error messages that are created by the miet crate are now working nicely for us. So we've got error handling down, which I was absolutely insisting on. We don't get too far into implementation before we get error handling right. I now feel pretty comfortable about that. So let's get back to the fun part of programs that we would like to run. So at some point we're going to have to stop just echoing things into standard input on our thing and let it deal with files, I guess. But we won't bother with that yet. What we'll bother with now is what I would really like to be able to do is parse a little program that does something useful. So let's write ourselves like an aspirational test, like this. And then this isn't going to pass for a while, maybe not in this video. But I think it's helpful to have like a guiding. There's sometimes in growing object-oriented software guided by tests. What's that called? It's called the Goose Book, I think. Anyway, in that book, which I've probably given the name of wrong, they talk about having a guiding test, and then you have smaller tests that kind of nudge you along. So let's have our guiding test. So let's say an assignment sets a variable value, something like that, right? So what I mean by that is we're going to have a much more complicated program than we've had before. We're going to say let x equal 3, and then we're going to say x plus 4. Like, that's still not quite a Rust program. Like, this could be the contents of a Rust function, which is close enough. It's close enough for now, yeah. So this program, if a lot of things come together, this program is going to print out 7, right? You put the number 3 into the variable, and then you can use that in an expression. So let's see what we can do with that. So by the way, there's a whole load of stuff that our code can't do. For example, it can't do 89 plus 11 if we just don't put spaces between the things, right? So we're a long way from this being great, but this seems to me like an interesting thing for us to tackle. And there's a couple of bits to this. First of all, there's recognizing an assignment. So we're going to recognize this let keyword, and then we're going to expect a particular type of token called a symbol. So we don't yet parse symbols. And then the equal sign, and then some kind of expression on the right hand side. Then we're going to need to recognize the semicolon to say it's a separator between statements, and then this expression, which doesn't end with a semicolon, so it ends with it like produces a value. That's so there's lots to do. Oh yeah, so I guess we should say this will end up as being equal to 7. So there's lots to do before this test passes. So I think I'm gonna, well, let's see it. Let's watch it fail first. It's going to fail just because there's a load of stuff in there that it doesn't know about. Oh gosh. Why is so much stuff failing suddenly? Did I change something? Okay, I guess our first job is to figure out what on earth I've broken that's caused all this stuff to fail. Alright, well, so this is the failure we were expecting. Like, it doesn't know what to do with the letter L, like the very first character of this thing. So that's what I was expecting. Now, what's gone wrong is, oh look, a load of stuff has colors in it. And all of our assertions say there shouldn't be any colors in it. And that's because somehow this Miette color off thing is not working, or we're forgetting to call it. So let's try and figure out where we might be not calling it, because hopefully that would be the nice thing if we just forgotten to call it, right? We call it here. Which tests are failing? So evaluating a number that is too long is an error. That's one that's definitely failing. And yeah, look, there it is. We are calling Miette color off and it's somehow not working. So I'm going to stop this video and sort that out before I do this. Okay, I'm back and I've figured it out. Yeah, I was using quite a dodgy way of doing this. So let's have a look at how this works. So these are tests where we've got an error message and we just don't want colors printed for it. So and the default way of formatting one of these errors that come from Miette, which is called a it's called a Miette error report. But so I think that's some kind of type def, because here it's just saying it's called a report. But anyway, point is that thing will come out in color. So with color codes in here, which just mess up our strings here, because we told it to use fancy formatting as a feature flag. So like, we don't want to change the feature flag because we actually want that in our real code. So what I was doing was running some kind of function that globally told Miette to stop setting the colors, and that's like it's a horrible global variable. So I don't know why it worked before and it doesn't work now, but that's the kind of thing that happens with global variables. So let's not do that. Let's find a better way. And the way that I've found, after a bit of fiddling around, is to wrap up that Miette error report in this new type that I've made called a no color error. No color error is just contains an error report, but it implements debug. So instead of us using the standard debug formatting for error report, we use this custom version of debug. What this custom version of debug does is create this Miette handler, which is the thing that like can format stuff for us. Set it to say I don't want any colors, and then use that handler to debug print our error, which is what this 0 is, the error report thing inside. And when we do that, basically, we've not got no nasty global variables. Everything's fine. We're creating a Miette handler that doesn't do colors and asking it to format for us, and it gets formatted. Maybe there's an easier way even than this to do it. Like, it seems a bit awkward that I have to kind of wrap it in this thing. I mean, I could just call a function that just does this stuff, but it's somehow nicer to wrap it up in this way, I think. So now, like, our actual test code doesn't look too bad, does it? It's just like wrap it up and format it, debug format. So, okay, so back to what we're actually doing. We run our tests, and our new test, which has all these new concepts in it, is failing. So we're going to ignore this test. I think we just do ignore to do that. And maybe we want to say a reason. Yeah, so look, now our test is ignored. And I think we can say guiding test, I think that's what they're called. Fails at the moment. So the next few videos probably are going to be spent trying to get this test to pass. Yeah. All right, look, it's telling us, look, why it's ignored. That's great, isn't it? Okay. So our guiding test is failing. So where are we going to get to first? Well, I guess the first thing is we're not actually able to lex this word let. So let's try lexing the word let. So we'll make a test here. And let's just find one of our standard ones. And I think what we can do probably is Lexing a whole assignment. Lex assignment statement. Let's say Lex assignment statement. It's not how you spell statement. And let's do let x equal 3 semicolon. We could even do the full example. That's probably a bit over the top. I don't know. It doesn't do us any harm, does it? X plus 4 was our example, wasn't it? And there's a few parts here. So like this variable's only got one letter in it. Maybe later we'll want variables. We'll definitely want variables that can have more than one letter in their name. So this test isn't like the complete set of tests for Lexing variable names or symbols. But it's something. So what it's going to be is it's going to be, I think it's going to be token. Now I don't know whether we're going to end up with, no, not token, sorry, keyword. I don't know whether we're going to end up with token : plus and so on and so on. At the moment, I feel like we've got a good compromise, which is at this stage, we just say it's a keyword. And the literal that creates it is let. And then later we'll like parse it out to be. Oh no, but the problem is, in order to even recognize that this is a keyword, we're going to need to recognize what type of keyword it is. So it feels wrong to recognize that and then not represent that knowledge in here. So maybe we need some kind of other thing here, like keyword let or something, just to, because like if we go through and say, oh, it was a let, and then we just make a keyword token and don't remember we recognized that it was a let, that feels a bit wrong. So I think it might look like this, and then some more stuff. So whoops, what did I press? Even this in itself is a little bit of a guiding test, isn't it? Because there's just too much in here. So we'll ignore this and just say guiding test again. And that needs to be in quotes. And let's make ourselves a simpler test that just lexes one keyword. And this is just going to be lex let keyword, let's say. Lex let as keyword. It's a little bit odd to me that we're recognizing keywords before we recognize symbols, so we might not even want to make this test pass yet, but let's just get our stuff written down. Yep, so basically when we see the word let, we should recognize it's a keyword and produce this keyword token. So let's just write a little bit of lex symbols. Let's just do some lexing of symbols. So, for example, when we lex x, it should be a symbol. And probably doesn't need this bit. And let's also do symbols that are a bit longer, like x, y, z, say. Oh, that should be x, and this should be x, y, z. And while we're here, should we do some more stuff? So soon we're going to do, well, certainly capital letters are allowed. Whoops. So I guess that would be like, oh, we can even have a leading capital. ABC would come out as ABC. And also ABC would come out as ABC. This is all probably fine. This is length 1, isn't it? But also symbols are going to be allowed to have numbers in them, but not at the beginning. And they're also going to be allowed to have underscores in them. Is that it for things that are allowed? Can we just represent them all here? Let's just make sure all the numbers are included, shall we? We're probably writing too many tests without making them pass. This is 11 long. And one more for good luck. We can have a symbol that starts with an underscore. Like this. So not just one more for good luck, but two more for good luck. F underscore capital G 17. Oh, I guess let's end with an underscore just for completeness. So just trying to think like what things could make our code break. And just represent them in test form. I'm sure there's loads of things I haven't thought of. That's all good. So there's too many tests. Half of them don't compile, and making them all pass all at once is going to be hard. So let's comment some of these things out, and let's just try and make the first assertion pass before we do anything else. So first thing to do is make there actually be like a symbol token. So we're going to provide a function called symbol. Like this. These are test time only functions, at least still at the moment. Some people don't call them symbols. What do they call them? Idents. But who knows what an ident is? So I'm going to call them a symbol for now, and we'll see if that causes us any pain. And we're going to make symbol, and that's also going to hold on to a literal. And for now, we're keeping, despite this to do that means maybe we don't want to hold on to the string, we're going to keep them in there for now. So is that enough to make our test compile and fail? No, we've still got some things because now there's another type of thing here. So where are we? We are in converting a token into a leaf token. So is a symbol a leaf? Yes, it is. So that means we've got to do something similar to the int here. Which is something like this, but it's not a leaf token kind int, it's a leaf token kind symbol, which we haven't made yet, so we better make one of those. Yeah, that looks fine, nothing much to be done now. So yeah, a symbol is definitely a potential leaf node in a syntax tree, so we have to support that. What else? Now if we're turning it, so a symbol is not a potential operator, so I think we can say anything except an operator token should give us this not operator token error. I think that's okay. So we've made this code a bit more general now. It covers both ints and symbols. And then here, there's multiple types of leaf token now. So I guess this should be, either of these are fine. It's kind of making me think this whole match here is not needed. We've got a leaf token, so I think we just need to, yeah, we like matching on the kind, but all leaf tokens, we've already checked that it is a leaf token, because that's what the OK branch is here. So we don't need this anymore. We don't need to match on anything. All we need to do is, we've got a leaf token, so let's pass our leaf token into the leaf or operation method. Much easier. Okay, what else? So we're not covering symbols inside that, inside this function that handles leaves. So we are returning a value. So this is the evaluator. We're trying to evaluate a symbol. All right, so that's definitely a to-do. We don't know how to evaluate a symbol yet. So we're going to leave that with a to-do in there. And we've got a warning that symbol's not being used, but I think we'll fix that soon enough. So our guiding test is still failing. No, sorry, this is not our guiding test. This is Lexing symbols. So, okay, so now we've written, we got the test compiling but failing. Now we need to actually Lex symbols, right? So, currently when we Lex things, we look for 0 to 9, which means so far that means it's going to be an integer. Later it might be a float as well, but for now it might be an integer. Or we find the operators, at the moment just a plus, or we find a space. And we need to say, what if it's a letter, basically? So we can say something like A to Z, I think. And for now, we do the dumbest possible thing, right? That's always our philosophy. If we just find an A to Z symbol, we return token kind symbol with, I guess we're going to have to recover its name like this. Soon this is all going to get much cleverer, but we're just going to do things one step at a time. And then this is going to be the same as this. Now, whereas operators for the moment, they're going to be one character long for a while. Symbols are very soon not going to be one character long, so we're going to have to get cleverer than this very soon. But with any luck, our first test should pass now. Look, it does. So with Lexing symbols is working. Now, obviously, it's not really because we've commented out most of our tests. So let's Lex some more difficult stuff, shall we? I think this video is about Lexing symbols, and then the rest of that stuff's going to come later. All right, so let's try a multi-character symbol. Try Lexing that. And we failed here because we just don't know what to do. Hold it. Oh, no. Oh, it's a good thing our test contains the letter Z. Because we've got a bug here, which is that Z's not included in this range that we made. Where is it? Here. So we went from A to Z, but we not including Z. So the way to make an inclusive range, like we did up here, is to say dot equals Z. So now Z will be acceptable, but when it found XYZ, it parsed that as an X symbol, a Y symbol, and then a Z symbol. And that's not how you parse this. So what this means is we need to do something cleverer, something more like what we did with integers, where we go and pull in all the other digits. So instead of immediately returning this token, we are going to call something called, I guess it's going to be called symbol, and soon it's going to be called symbol or keyword. But for now, we'll just call it symbol. And it's going to look a bit like int, which just draws in all the characters. So it's called symbol. It takes a mutable reference to self. It takes in the first character, returns a token, and we'll paste in what we were doing before, even though it's not right. And then we're going to do something like this. Basically, read in characters. So start with a string which is that includes the first character. And I think at some point we're going to end up with some help from the struct that we're in. So instead of passing in this first char, maybe we store it inside self, like what we've built up so far or something like that. But we'll do it the dumb way and we'll gradually work our way to a better solution. Right, so pos offset is this thing of if we get past the end, we need to take one off. So we're going to need we need to take one off the byte position of the token, right? So yeah, so that's still relevant. The point is, in order to go through, now that we know it's a symbol because it started with a letter, now we need to keep adding things, keep adding characters until we've got something that's not allowed. Oops. In a symbol. So just pull characters one by one. If they're A to Z, we're okay. We just push them in. If it's something else, we break and return a token of type symbol. We can get rid of this because that was just what we were doing before. And yeah, all right. So now it starts with A to Z, and then any A to Z that we find later is also fine. So this should pass our next test, I think. Yeah, where Lexing symbols is passing again, because so far our test only checks lowercase letters. So now let's try an uppercase letter, like this. That should fail, because the capital A that we included there is not. So this is what this is me doing like extreme test-driven development, you might say, where I'm not implementing anything until I've actually definitely got a test for that thing. So now uppercase letters are okay. This should be binding to whatever. Oh, hold on, we're not using sim, so why have we got it? We're using ch instead. So we don't need this, and that means we also don't need op. So I was being a bit silly here. Basically, we've got ch already, so we can just pass in ch. Oh no, we actually even did that up here. So that was just a waste of fanciness. Whenever I see the @ sign in a pattern, I think to myself, am I being too clever? Is there a dumber way to do this? In this case, there definitely was. I was just totally wrong. Okay. All right. So now that A to Z, capital A to Z was also allowed as the beginning of a symbol. And apart from underscore, I think we're done on things that are allowed at the beginning of symbols. But inside symbols, we're still not allowing capital letters. So that's interesting. We had a test that only checks the first letter. So now let's enable our next test. And it should fail. Now you might say these should all be separate unit tests. But I think like they're quite unlikely to start failing in future. Like the reason why you'd break a test up into multiple tests is because if in future one of them fails, it's easier to deal with if it's a completely separate test with an explanation of exactly what this thing tests and things like that. I wish I had a better name for this test. That would immediately make it easier to debug when it failed. But to be honest, these aren't really going to fail in future. So cramming them all together makes it quite easy to see. Like my definition of a symbol is it's got to look like it's allowed these things, it's not allowed these things. So it's what I'm going for. All right, that fails because capital B is not allowed within a symbol, because our code that looks for the remaining characters of a symbol doesn't allow capitals. So let's make it allow capitals. Like so. And we're back to parsing again. So let's make our test fail by enabling the next bit. I'm just adding a marker. Right, so now numbers are allowed, but not at the beginning, but later on they're allowed. So that's going to fail. So let's make numbers. Hold on. That's right. Oh, but this test is wrong. That should be length 2. Yeah. So let's fix that by allowing numbers, but only inside a symbol. The beginning of a symbol has got to be a letter or underscore. But once we're inside a variable name, you're allowed numbers in there, aren't you? That's pretty normal. Should pass. Does pass. Right, next one. Now this one is just a lot of numbers, so I think this one is already going to pass. Yep. Okay, and now starting with an underscore, it's going to fail. So let's go back there and look for starting a symbol. So you can start to see the structure that we're building up, which is basically match on the first character and then decide what we're doing. Like let that first character that we see of our token decide what type of token we're expecting. And so far it's splitting up quite nicely, isn't it? Like if it starts with a number, it must be an int. If it starts with a plus, it must be an operator. If it starts with a letter or underscore, it must be a symbol. Now where things get complicated is, actually, this might be a symbol or it might be a keyword, right? So we're going to, instead of calling just out to symbol here, we're going to call like symbol or keyword or something like that. And similarly, this 0 to 9 might be the start of an integer. It might be the start of a floating point or some special other numeric literal or something. So instead of being int, this is going to be int or float or something like that. So we're going to end up with functions that don't yet know the exact type of token they're going to return. And they're going to have awkward names like symbol or keyword or something. Like maybe we'll find a better way of naming them. But yeah, somewhere inside here, they're going to decide whether this is a symbol or a keyword and then return the right thing. So, for example, in the numbers here, it's going to say, if we find a dot, well, then this looks like a float, not an integer. So we're going to call out to another function called float from a function called int or float, something like that. Anyway, so what did I do? I just allowed underscores to go at the beginning of symbols, and that worked. And what about underscores in the middle of symbols? That should fail. So let's allow underscores in the middle of symbols. And then according to my set of tests, we're done with the definition of a symbol. Now, if you've ever seen any formal grammar description, oh yeah, that test is wrong. Because it should be 7 characters long, not 2. And we're passing. So have you ever seen any formal grammars? In a way, this kind of looks a bit like them. So, but it's split across 2 places. So, a formal grammar would say something like, it must be a letter or underscore at the beginning, and then the next letters must be, letter or number or underscore. So we're kind of representing the same kind of thing that you would write in a formal grammar in code form, but we're kind of unrolling it. If you wrote it in a formal grammar, you'd say it's either a symbol which has this definition or it's a keyword which has this definition, but we're going to kind of we're going to write the code that would get generated by some kind of thing that understands your formal grammar and then spits out code. And we're just handwriting what it would spit out. So now we've got parsing Lexing of symbols done. So what's next? Now we need to say, look, even though let looks like a symbol, doesn't it? Because it's made out of letters. Actually, it's a keyword. And it's specifically the keyword with the definition let. So we're going to need to make a function called keyword. And it's taking in that literal again. So I'm being a bit extreme about like taking in literals for everything. Maybe we ain't going to need these at all. But yeah, all right. Well, but for now we are. So this, I guess, I'm going to call keyword. That's what I called it earlier. And I might regret that name. Maybe it's a keyword kind or something like that. And this is going to be a token kind keyword, which holds on to both a literal and a thing, which is basically we figured out which keyword it is. So let's generate that. It's going to be a string and a keyword, and it refused to generate that code because this keyword thing doesn't exist yet. So we're going to have an enum called keyword. And that should be debug and partial leak, same as everything else. And we're going to list all the keywords in here eventually. But for now, whoops, no. For now, we're going to say there is just a thing called let inside here. And all the other keywords in the language are going to end up in this list. All right, where have we got to? When we are converting a token to a leaf token, could that leaf be a keyword? That's a good question. How does that work? I think not. For now, at least, I'm going to say no. There's no keyword that is just like on its own in the parse tree. It's always going to be a keyword's always going to be useful as something that makes a bigger parse tree, I think. Or maybe the return keyword might end up being a leaf, or maybe that is itself like a special syntax tree which just consists of one thing. We'll figure that out later, but for now, the stuff we're recognizing, we're never going to have a syntax tree which is just a keyword. I think I'm already doubting myself, so we'll see whether I've forgotten exactly how these leaf tokens are used. Maybe they are just the beginning of an expression that ends up being a compound. We'll see. So for now, we're nearly there. So now we've got a failing test. All the work we've done so far is just allowing us to kind of assert that this keyword should exist. Now we have to write the parsing code that actually says that it does exist. So not the parsing code, sorry, Lexing code. So what we said was, if it starts with a letter, it's a symbol. But what we mean is, it's either a symbol or a keyword, right? Because those are the things that start with a letter. And in principle, we could say, well, all keywords always start with a lowercase letter. So we could be a bit smart about this and say, if it starts with an uppercase letter or an underscore, then we already know it's a symbol, not a keyword. This should be called symbol or keyword, like so. But I don't want to be that clever, because what if later I create a keyword that starts with an underscore? You know, like Python has some words that start with underscores. Maybe we're going to want them someday. It just doesn't seem like a useful distinction for me. So I'm just going to say symbols and keywords have the same like Lexing rules. It's just that a certain set of words are not allowed to be symbols because they're keywords. Yeah, so it normally, if the parser sees the word let, it's just not allowed to be a variable because it's a keyword. And we can try that out, right? If we just make a little Rust program here, let's just make a temporary directory, like so. And we say, I don't know, let's say let equal 3, right? It's not allowed because we expected an identifier. All right, so see, Rust calls it an identifier. Maybe I should be calling it an identifier as well. Maybe I need to rename symbol to identifier, because we did say we were writing a mini Rust, so we're going to use the same wording as Rust. I think it's probably good. Yeah, so let is not a symbol or not an identifier. It is a keyword. That's my only point here. So let's just get rid of that. Probably didn't need all that rubbish. I could have done that in our main source code, but anyway. Yeah, all right. Renaming to come soon first. How do we actually do this? We pull out all the letters until we've got this thing called ret, which is like the symbol that we've constructed, and then really it's just a matter of calling some kind of function, self dot find keyword on ret, and it basically, if that comes back as a keyword, then we need to return a keyword token. Otherwise, we return this stuff here, something like this, right? I guess we should pass in like a reference to ret, and I don't think ret is a good name for this anymore. But if we did find a keyword, then this is going to return a keyword token with ret in it, and also the keyword that we found, because that keyword token kind of takes two arguments, a string and a keyword. So find keyword doesn't exist yet. So have you noticed I often make up functions that don't exist yet to help me think through what they should do before I write them. Right, this len is going to get used. So we said we'd rename ret to, I mean, I think this is literal. Literal. Right? It's the actual sequence of characters we're using to construct our symbol or keyword. Now we need to make a function called find keyword. And is this really going to be something? Is it really a function on keyword? Is it actually just keyword from literal, something like that? So we don't need this find keyword function anymore. We just need to implement something that makes a keyword from a literal. And either returns none or some. So I guess it would be try from. And this would be if it's okay. That's the standard way, right, of making something. You say, okay, make me a keyword from this literal. So I guess look up, whether this literal I've got is one of my listed keywords. If so, return it. Otherwise, return an error. Is this a sensible thing to do, or should it? I don't think this should be try from. I don't think it's really a try from. I think it's kind of new, but it's more than just new, isn't it? It's new if something. Oh, what is it? It's like match or find, or what about find for now? I'm not sure that's a good name, but it's a name, and we better write some comments to help ourselves out with the fact that it's a name. If the supplied literal is a keyword, return the keyword. Otherwise, return none. Is a known keyword, I guess, something like that. All right. Now, is there something clever we can do to say? I mean, there's certainly something dumb we can do, right? And we tend to start with the dumb thing. So we can match on the literal, and if it says let, then we return let. Oh, I guess we return some let. Otherwise, we return none. And I think that is going to be good enough for us. The only thing is, like, there's the repetition here, isn't there? There's let and let. And in principle, we could probably use some kind of macro on keyword to say, allow me to iterate through all the things in this enum, and for each one turn it to lowercase, and then we know whether. But at the moment, I think I'm happy with doing this manually. I think I prefer doing this manually. We'll see. And the only thing here is that I feel like I've got a lot of stuff in one file, which I think should actually be in more than one file. I really don't like this name find. Check. Let's call it check. Basically, we're checking whether this literal is a keyword, yes or no. Okay, so any errors? No. Any tests passing? Yes, so now let is getting lexed as a keyword. Let's go back and look at that test and check we think it's sensible. So yeah, we said when I see a let, it should come out as the keyword let. So how close are we to our guiding test passing? Well, the equals symbol is not yet recognized, so it's definitely going to fail there. Hold on, what happened? Oh, we're ignoring it. Okay. That was kind of scary. Okay, so yeah, the equals sign is not recognized, the semicolon is not recognized, and also our test doesn't actually represent reality because at the moment we're only saying it should contain one token. So it's definitely going to contain a symbol X, and that is going to be from 1, 2, 3, 4 to 4 plus 1, and then it's going to contain something else. Is it an operator? Is equals an operator? I think for now we're probably okay with it being an operator. Later it might need to be some more generic word like a punctuation, or no, it's not punctuation, but something like that. Then we're gonna, I guess, we're gonna have a special name for semicolon. Oh well, we've missed one. So then it's going to be an int 3, which is going to be from 8 semicolons at 9. And then it's going to be another symbol, which is at 11. And then an operator plus. And then an int 3. And let's try and get their positions right. We're bound to get this wrong, by the way, but we'll get it near enough. Whoops. And so, like, why is semicolon special? We could just say all things like pluses, equalses, semicolons are the same kind of thing, which we're currently calling operator, which is now a really bad name if that is the case. But I have a feeling, because semicolons are pretty special. So, if it was 3 and then a plus, that would mean something very different from it. It's a 3 and then a semicolon. So I think that's right. I also think this equals is not an operator, because if it was like 2 equals 3, that would not be a valid operation. So let's think what we're going to call this. An equals sign. I mean, we could just call it equals. Let's call it equals for now. And we may get more and more specific with our symbols as we go. So with this, we may end up with a token : plus instead of a token : operator, but we'll see. I think essentially what we're coming down on now is that everything that's suitable to be bunched up in the parsing step into an operation should go in operator, and then stuff that's not suitable for that should be its own type of thing. So I think that's making sense, that when we're finding the types of the tokens, we've got parsing in mind, even though we're at the Lexing stage. All right, so let's make ourselves these things. And I think if we can get the whole thing to Lex, that's probably the video. We've Lexed quite a complicated thing. So let's make an equals. In fact, it's going to look a bit like operator, isn't it? So for now, it's going to be equals. Its token kind is going to be equals, I think. And that's it. And while we're here, we'll do semicolon as well. Wonder what order these go in. Semicolon, all one word, no capital in there. We'll generate an equals variant, we'll generate a semicolon variant. We don't need any special stuff, so they just hold on to strings. I think now our test should compile. Where were we? Yeah, Lexing the assignment statement is where we are. So let's see if it's okay. So now our test compiles, but it fails because we're not yet parsing equals signs. So like Lexing equals signs. So let's go to our production code again. And at the moment we are parsing Lexing numbers or integers, operators, symbols, spaces. So somewhere around here we're going to do, oh, we didn't put a comment in. We should put a comment in for symbols or keywords. Symbols and keywords, I guess. We haven't renamed symbol to identifier yet, but we will. All right, so this is going to say, if we see an equals sign, immediately stop. For now, because sometime soon there might be an equals, but for now we're going to say stop immediately. We found an equals sign, and we're done. And then what else? So this shouldn't be operators. This should be special things. That's a terrible name. And as we think of better ones, we'll fill them in. All right, so semicolon. Again, and this time, like, I don't think there's ever going to be an operator which is a semicolon and then something else. So I think that's okay. It's always going to look like this. All right, so how does our Lexing go? Something went wrong, and this is it's not a very nice thing to have strings to compare, is it? All right, so it's a let from 0 to 3. It's a symbol X from 4 to 1. It's a equal sign from 6 to 1. It's an int from 8 to, sorry, not from 8 to 1, 8 and 1 long. And then we've got something, no, that's right. And then it's a semicolon. What's happened here? So we've got let X equals 3 and then immediately X again. The semicolon's been missed. The semicolon's been missed because we've got a problem in our parser, which is we're going to be forced to fix at some point soon in our Alexa, which is that we consume an extra space. So I'm going to cheat. I'm going to cheat for now, and we'll fix this next video. I'm going to say, let's put a space in here, because when we read this 3, we consume the next character after it. So if I cheat in my test, then we'll end up with our semicolon. It's from 10 to 1 instead of, right. Of course, our I messed up our numbers by cheating. You always get found out when you cheat. We're still not there. 10 to 1, and then x from 12, 12, 1, plus from 14, 1. Oh, and then we did another mistake. This should be the int 4. It would be really nice if that was an easier to read diff. I think maybe if we used, is it called new test? There's some like a nicer testing library that we could use. All right, so I think we got somewhere. I think we got far enough, which is that our guiding test for Lexing is passing with this caveat that these spaces are consumed. When I said the next video, what I really meant was once we've got our guiding test for parsing working. No, our guiding test for evaluating. We are going to go all the way towards having this test. I'm going to put I'm going to put the cheat in here. We're going to go all the way towards having our guiding test pass, including supporting variables, before we fix this horrific problem that we consume the next character after the 3. Hope you're enjoying. See you next time when we are going to try parsing this assignment statement, which I think is going to be a bit of fun. It's quite easy because it lets us know what's coming next. All right, see you then.